Welcome everyone, Mechanical Bus, and today this is the fourth video of my channel, and today we will talk about the knocking and detonation of an petrol engine. And from the last videos, we have come to know that the combustion process briefly, and the four-stroke SI engine principle, which is very much compulsory for us to study this combustion process. So no more talks, let's jump to the lecture. So what is actually knocking and detonation, right? And there's some controversy or going on between knocking and detonation. Whatever it is, but in very easily, if we try to understand it, we have to think that inside a petrol engine there happens a combustion after the compression stroke, and in the power stroke a combustion happens, and this combustion can be a normal combustion and an abnormal combustion. Okay, so we will talk about the normal and abnormal combustion. Going to the knocking and detonation, we will first try to understand the normal combustion that we have been discussing for the last three videos. Now we will have a very little glimpse of normal combustion. Actually, what we have studied from our last videos, as you can see here, two diagrams. The upper diagram represents the cylinder pressure, and with respect to time, this diagram actually is a cylinder. What happened actually in normal combustion, as you know that the combustion actually occurs after the compression stroke. So after the compression stroke, the pressure inside the cylinder pressure increases, and after power stroke, then pressure decreases. Okay, and with the increase of and with the changes of crank rotations, or what should I say, crank angle, and with time actually. This is how the curves of the normal combustions, right? The pressure rise, boom, and the power stroke here booms up, and then the pressure decrease. Okay, that's what happened in normal combustion. And as if we see this according to the stages of combustion here, the normal combustion, this diagram actually represents the normal combustion according to the combustion processes and the combustion stages. Here actually, from BDC in compression stroke, we know that the piston goes from BDC to TDC, and it is going to BDC, and the pressure actually, this represent the pressure in the vertical axis, represent the pressure, and then the pressure is increasing, and here the ignition actually starts from here, and then the combustion starts actually. I'm not talking about the ignition lag here actually. So the combustion occurs and happens, and the power strokes happen, and then the pressure decreases, and the piston again goes from TDC to BDC, and that's how it works actually in the normal combustion. So if you have any doubt on that, you can go back to the videos, and also you can recommend me if I have missed anything in my past videos there about normal combustion. So this is what the normal combustion is. And another thing is that in normal combustion we have to look at very closer. Suppose this is a cylinder, as I have drawn here. This is a cylinder, and this one is piston. And in normal combustion, actually, after compression stroke and after ignition, actually, what you can see in this diagram, and after the after spark plug sparks occurs, then the pressure actually, goes uniformly. Okay, the self-propagation stage, which increases in accordance to the pressure inside the cylinder, and it happens actually the shock waves of the pressure and the shock waves of the explosion that we have actually studied from our past videos, that an explosion happens after compression stroke in the time of power stroke. Then the explosion have uniform shock waves there. But what happens actually in abnormal combustion, The abnormal combustion is that if there is taking another combustion which is unexpected and which is not the objective to design an engine actually. We actually wanted normal combustion inside the cylinder. That's how the power actually developed, and that's how an engine works efficiently. But in abnormal combustion, you will have two combustion inside the cylinder. The first one that we want, but the second one that we don't want actually. So the second one is the topic of today's video, and that is called the knocking and detonation. So um, to describe it with a shock waves representation over this drawing. In normal combustion, as we can see, the shock wave will go uniformly, but in abnormal combustion, what happens actually, an abnormal combustion will take place in the end of in the sides or in the end of the burned charges or unburned charges here, end of the cylinder, okay, end of, or you can say the end portion of combustion chamber. This will take another shock waves here. So one combustion, number one combustion, and second combustion here. Okay, so these two shock wave will collide with each other and will make a vibration, abnormal vibration in the cylinder, and which will actually lead to mechanical damage and also noise and vibration, which is not actually the objective of to design an engine. So what is the main story here about the abnormal combustion is that during abnormal combustion there will be two combustion. The first one is the normal one and the second one is the abnormal. Now we have to look at why this happens and what is the name of abnormal combustions. So as I'm actually talking about the abnormal combustion, we'll start from the edge of the combustion chamber. From it can be from here to here, whatever, but in the end portion of combustion chamber. So when two shock waves, the combustion number one and two, uh, collide with each other, as you can see, it will intersect. Okay, and linearly we can say that it is intersecting one another. But when it collide, actually, it will make abnormal vibration, and that is called knocking. Actually, that is called knocking. Now, if you look at this diagram, we will not talk about right now. This is out of our topic right now, as because we have we had a brief description about it a couple of minutes ago. So we will talk about the combustion, abnormal combustion, starting from here. But why the abnormal combustion actually occurs and what are the stages of that? Here, actually, the normal combustion happens for auto ignition, and also you can say pre-ignition. But these two things have these two terms are different actually. Auto ignitions and pre-ignitions are the different things, but these these two are the main factors of knocking and detonation actually. So let's just look about the diagrams. What happened actually when normal combustion happens. So we have two kind of knock, and what is knock? I've already said that knocking is something takes place inside a cylinder, and abnormal combustion there, as you can see here, in abnormal combustion it can be here or here, whatever. So according to the intensity of or the speed of knock or the amount of knock, you can actually categorize two kind of knock there. One is light knocking and the second one is heavy knocking. So as you can see that the pressure actually, this represent the vertical axis represent the pressure. When the pressure increases here, okay, the pressure increases. It was actually started before, so I'm taking from here actually. So the pressure increases and the compression stroke is the piston is going to BDC to TDC, and the pressure increasing and increasing and increasing, and combustion occurs and power happens. But here, as you can see, the vibration here is not actually in a uniform, in a uniform slope here. As you can see that this is very this is actually a uniform one where there is no normal combustion is taking place. As due to the normal combustion, you will have some uh, what can I say, the 6 and 7 here actually. So this represents the knocking here, But the difference with this diagram and this diagram is that here is actually this diagram. You can see that the knocking is quite light, bit of respect to this one, because here the knocking is so much that it represents so much curves here in the normal curves. So this one is heavy knocking. This represents the engine will knock very much, and this will lead to detonation. Okay, this one you can say it's a knocking, and this one you can say detonation. So the heavy knocking you can say actual detonation, but again there's a lot of controversy happening between knocking and detonations, because a lot of specialists are saying actually taking off or defining them from different theory or their thought process actually. But here actually in the basics of our video we can say that the light knocking is actually knocking, and the heavy knocking we can say, or we can term it as detonation, whatever it is. But right now we have to actually see this diagram, the abnormal combustion here, as from the corner of ignition stage. So you can see that the compression stroke happens, and piston climbs up from BDC to TDC. The piston is going up and the pressure is increasing, and this point, as we can see, this is the ignition point when the spark plug actually occurs, spark or gives spark, whatever. The pressure increase and the piston reaches to the TDC, and again it's come down to VDC, but the pressure is increasing due to combustion, and the power happens. And right now this one is normal, because the vibration is not in a uniform motion, in a uniform way, or as we have discussed here, there's some 6 and 7 curves here. So this one is knocking, and then again it's going straight to BDC. Now we actually try to have a look on knocking and detonation, and we have come to know that detonation is something that is unexpected inside a cylinder due to combustion, and or other way it's another combustion. But now, as we know that the combustion happens only for spark plug, but the second combustion, which one is abnormal, what we are talking about, the knocking, why it's happened actually, because there's no other igniter there to ignite actually the mixture. Okay, don't talk about the dual spark plug system, that is a different issue. But apart from the allowed igniter or spark plug that actually the designer put into it, without that, if there is anything that actually creating spark or creating ignition, that is undesirable. Okay, so the first course is the auto ignition. So auto means self actually, or you can say that is self ignition. So auto ignition is something which actually happens without any igniter there, or without a flame actually. You can say the perfect term for auto ignition is, this is kind of ignition which actually takes place inside a cylinder but without a flame actually. But why and how? To understand this, we have to look this diagram over here, and before that we have to familiar with two terms here. The SIT, which actually indicates self-ignition temperature. This is the temperature or the point of temperature where the self-ignition start to proceed, and the ID means the ignition delay here. That the curve represent is what is actually representing here. The vertical axis represent the temperature here, and as it is go or it move upward, it actually increases the temperature here, and this point is the point that the self-ignition start to occur. Right now, why auto ignition happens actually? If the temperature stays equal to the SIT, if the temperature stays equal to the FIT, or higher temperature, but it has to stay for a finite time. Okay, temperature is rising and rising and rising, but it has to stay here for some time. Like if your temperature is staying here in this point, then auto ignition will happen. And also if your ignition, or sorry, if your temperature is staying higher than the SID point here, and it is staying actually for a finite time, then the auto ignition actually start to proceed. Now, the term actually and I'm sorry, I'm just going through 6 and 7 right now. And another thing, ignition delay is what? As you can see that uh, this one curve represents the self-ignition. So imagine that the piston is going up to from VDC to TDC, and then the temperature is increasing, and it reaches to the SIT or self-ignition temperature. And here is the curve. As you can see that the temperature stay in this point, and actually it is staying for a time. This one represents actually the time, and it is actually staying for a time, and then this is the point when the self-ignition or the auto-ignition happens actually. So the horizontal, actually the horizontal axis is representing the finite time at which the temperature it is staying for that finite time actually. So the curve here, the bending curve here actually represent the self-ignition or the auto-ignition time of the point here. So in second curve, as we can see that the pressure is increasing and the temperature is increasing here, and then the temperature is staying for a finite time, and it's staying, and here in this moment or in this peak point, auto ignition occurs, and actually the abnormal combustion happens, or you can see that this one is starting to proceed in this point. And the third one, as we can see that this one is staying for a very short time, and it is actually taking very short time. Now you can see that the difference here, the three curves here, and the difference is the time, the delay time that it is started to staying that temperature to the auto ignition point, and that time and that delay is called the ignition delay here. Okay, so you can see that whenever the temperature is increasing, the delay time is decreasing actually. So why the delay time actually decreases, and what is actually the actual cause that alter the ignition delay or the delay time? So the delay time is a function of compression ratio. So what is compression ratio? We already, compression ratio is very basic. The ratio between the total volume and the combustion chamber, or sorry, the combustion volume is called the compression ratio. As the compression ratio increases, the delay time decreases. It is actually inversely proportional to each other. The ignition delay, if the compression ratio is less than much lower, then the ignition delay will increase. If the compression ratio is much higher, then the ignition delay will stay for a very short time. So that was the cause that we can have petrol engine much more than much more than 16:1 actually. We can go above 16:1 ratio in petrol engine because of this phenomena here inside a cylinder of a petrol engine. So, but in terms of diesel, you can go actually further on that, because diesel fuel actually has a character that it doesn't actually occurs auto ignition even in higher compression. So that was the difference actually. The main factor here is the fuel quality, or not fuel quality, the types of fuel, or its flash point, or blah blah blah. We will talk about it later. So auto ignition is something that happens inside a cylinder without any flame, or as you can see here, the self-ignition carbs. You will must understand it. I hope that. And the last one, we will talk about the pre-ignition here. So the cause of auto ignition, as we have discussed here, but the cause of pre-ignition is the cause of auto ignition actually. After auto ignitions, you will have a much more temperature inside a cylinder, and it will project any parts inside a cylinder much more hotter than before auto ignition actually occurs. That's mean the preignition happens actually for any projected parts inside a cylinder which has now a hotter situation than before auto ignition. For auto ignition, there were an abnormal combustion take place, and that's why the heat transfer actually increases inside a cylinder. And for that reason, the inside the cylinder, the parts like the valve and piston, spark plug, especially spark plug electrodes, gets very hot, and that's why the next cycles of any engine after auto ignition, the normal combustion happens for preignition. The difference between auto ignition and preignition is auto ignition happens for self ignition, but the preignition happens for external causes like the contacting with the hotter spot of any parts inside a cylinder. Right now, we have discussed about these things here. What are the So right now we will try to actually understand what are the defects of knocking or detonation inside a cylinder of an engine. Knocking and detonation have a two damage, right? Two bad effects like abnormal noise or a roughness of engine, and the second one is mechanical damage. And in upcoming video we will try to explain it, what are the damages and what are the disadvantage of knocking and detonation. And till then, stay safe and stay home, and try to use hand sanitizer to protect yourself, and stay well in this during this pandemic, and try to learn something new. Till then, stay safe and stay good. Bye bye.